In this video, we are going to take a look at the graphical aspect of vectors, our first lesson on vectors. Before we get started, we want to define what a vector is. A vector is a quantity that has two things, both magnitude and direction. So if we look at the vector that we're given to start with, we're looking at the vector PQ. P is the initial point where it starts, and Q is the terminal point. So it has direction because the arrow is showing us that we are going from P to Q. And there's two different labels that we can give this. We can give it this first label of PQ. We can label it with a lowercase letter, vector V. U, V, and W are popular letters, lowercase letters used to represent vectors. And then our magnitude is the distance only. So taking away the direction, the length or distance from the initial to the terminal point. And just like with matrices, we have special notation for the magnitude. We have a double bar on either side, so kind of like absolute value symbols, but that represents find the magnitude. So if you see the double bars around the vector, it's telling you to find magnitude. It doesn't have to say that in the directions. All right, so there's some different ways that we can write or represent the components of a vector. We have what's called a position vector. And the position vector is going to slide the vector down to the origin. The initial point is always going to be at 0, 0. So I'm just going to include that in the pictures down here. The vector could be somewhere off here, but we're going to take that vector and we are going to move it and slide it down into that space. So we're moving the vector to that origin. Now, in order to find the magnitude of the vector, we are going to be looking at distance formula. And I'm going to do a 2D and a 3D distance formula here. So we're looking at x2 minus x1 squared plus y2 minus y1 squared if we're doing it in 2D. If we want to expand it out to 3 dimensions, we're just adding in a z value. Now the 3D needs more of a visual than it can be given on a video for certain aspects, so this video will only do the things that we can do in 3D that makes sense for a screencast video. The magnitude itself is going to be plugging in the points that we're given using the initial as the origin, and then we're using A and B to represent our terminal points. So since we use the origin, we can simplify this down into a squared plus b squared. If we do the same thing over here, but add in I meant to put a 0 here, sorry. A c minus 0 squared, we're going to get something very similar for the magnitude. A squared plus b squared plus c squared inside of that square root. So we're just going to take a look at how to use this information to draw vectors in a few different ways. Our first method is just going to be taking an initial terminal point and then coming up with the vector in component form that we would slide in and make a position vector. So if we plot our 2 points here, -2, 7, that's our initial point. Just color code that for you. And then the terminal point is 3, -1. Our vector has to go in that direction from the initial to the terminal point. So what we're looking at is the actual direction that we're going in. We want to put this in component form. So when we put it in component form, it's kind of like slope. We want to think about left and right, and then up and down. So first, left and right, to go from the red point to the blue point, we have to go to the right 5. And we can either write it in a V bracket for vectors, or the other format is 5I, and then we're going to use J for the component for the Y. And then we're going to the right and we're going down. So since we're going down, we want to put negative. That's going to represent going down, and we have to go down 8. And those are our 2 formats that we can use. And then our magnitude of our vector is going to be the square root of 5 squared plus 8 squared, which will give us the square root of 89. If it's possible to simplify, you will. In this case, we are not able to. And then the last thing I want to think about here is if I were going to make this into a position vector, which I'm going to put in green, I would slide the vector to the origin, and then I would go to the right 5 and down 8. Goes a little bit off the graph. Don't add this onto your own graph. I just want to show you the explanation of the difference between a vector that's floating up in space in your rectangular coordinate system and the actual position vector, which is what we're finding the component forms of. The component forms are going to be key for doing algebraic work with our vectors later on. So I'm going to stop this first section of the video here, and then we're going to move on to adding and subtracting position vectors, doing scalar multiplication with them, and doing a little bit of 3D work in the second video.